Hello. Today our topic is coefficient of variation. Okay, coefficient of variation. Um, Coefficient of variation. We'll okay. First we'll see the introduction. Relative measures of standard deviation is called coefficient of variation. Standard deviation is an absolute measure, and relative measure of standard deviation is called coefficient of variation. Carl Pearson has introduced this measure in 1895. According to him, coefficient of variation is percentage variation in the mean, the standard deviation being treated as the total variation in the mean. The coefficient of variation is used to compare the consistency and uniformity of two or more distributions. In order to know the consistency and the uniformity, we use this coefficient of variation, right? Lower the value of coefficient of variation means higher the consistency, more uniformity, and lower variability. Okay, uh, the formula symbolically we can show this, okay, as CV, coefficient of variation, is equal to sigma, that is small sigma, which is called as standard deviation, by x bar is equal into 100, where only coefficient of standard deviation we have small sigma by x bar, whereas coefficient of variation is nothing but that is expressed in percentages. Hence we need to multiply with the same with 100, that is small sigma by x bar into 100, where CV is the coefficient of variation and small sigma is standard deviation, x bar is arithmetic mean. Okay, both coefficient of standard deviation and coefficient of variation are the relative measures of dispersion. Both are relative measures of dispersion. The distinguishing feature between them is that while coefficient of standard deviation is the ratio, okay, of standard deviation to mean, and the coefficient of variation is its percentage. Okay, when we are expressing the coefficient of standard deviation in percentage is called as coefficient of variation, right? To understand better understanding, we will have a numerical problem here. Okay, a calculation of standard deviation and coefficient of variation. Okay, uh, he has given calculate the coefficient of variation and compare the consistency of the following distribution. He has said he has given two distributions and asked to compare. He has given class intervals 0, 50, 50, 100, 100, 150, 150, 200, 200 to 250, 250 to 300. This is the classes that were given by the examiner. And distribution A, distribution B. Distribution A, between 0 50 class interval we have 2.3, 550, 100, 1.7, 100, 150, 2.0, 150, 200, 3.3, 200, 250, 2.7, 250, 300, 4.7. Whereas distribution B, between 0 50, 1.8, 50, 100, 3.2, between 100, 150, 4.0, between 150 to 100, 4.8, between 200 to 50, 5.0, between 250, 300, 2.4. Okay, here for the sake of convenience and know easily, uh, which were given in the problem are indicated with red color, and what we need to solve taken as in black color, okay, shown on black color in the PPT. Now we need to calculate mid value from the given data. Mid value, how could we get the mid value? If you add the upper limit and lower limit, then divide by the 2, you will get the mid value for the given class. That is 0 plus 50 by 2 is equal to 50 by 2, 25. 50 plus 100, 150 by 2 is equal to 75. 100 plus 150, 250 by 2 is equal to 125. 150 plus 200, 350 by 2 is equal to 175. 200 plus 250, okay, 450 by 2 is equal to 25. 300 plus 250, 550 by 2 is equal to 75. These are the mid values we got from the given class interval. Right, next, mid value, we need to consider deviations. Okay, deviations which are taken from the mid value. Okay, from the assumed mean. Mid value minus assumed mean. Okay, here assumed mean, and in order to make it easy, we are considering a common factor that exists in the mid value. Okay, mid value figures are very big, hence I want to reduce them by making them into with a common factor. Okay, common fact, taking a common factor. Here we have taken that assumed mean. Assumed mean is nothing but mid value 25. Okay, 27 is the assumed mean. 25 minus 27 is equal to minus 2. Okay, uh, sorry. Okay, assumed mean is 125. Okay, 125 is taken as assumed mean, and 125 minus okay 125 is taken as assumed mean, and MV is 25. 25 minus 125 by common factor is the class interval taken as common factor, that is 50. Okay, hence 125 minus 100 is equal to 125 is equal to minus 100 by 50 is equal to minus 2. Then second one, 75 minus 125 is equal to minus 50 by 50 is equal to minus 1. 125 minus 125 is equal to 0. 175 minus 125 is equal to 50 by 51. 225 minus 125 is equal uh, 100 by 50 is equal to 2. 275 minus 125 150 by 50 is equal to 3. Then we need to multiply the same deviations with the given corresponding frequencies, that is minus 2 into 2.3 is equal to minus 4.6. Okay, minus 1 into 1.7 is equal to minus 1.7. 2.0 into 0 is equal to 0. 3.3 into 1 is equal to 3.3. 2.7 into 2 5.4. 4.7 into 3 14.1. Okay, then we need to square the deviations, that is minus 2 into 2. Minus 2 into minus 2 is equal to plus 4. Minus 1 into minus 1 plus 1. 0 into 0 0. 1 into 1 1. 2 into 2 4. 3 into 3 9. Now we need to multiply these with the corresponding frequencies, that is 2.3 into 4 you will get 9.2. 1.7 into 1 1.7. 2.0 into 0 0, and 1 into 3.3, that is 3.3, and 2.7 into 4, that is 10.8. 4.7 into 9, 42.3. This is the distribution given for A. Okay, now we take distribution of B. Okay, he has given that frequencies are given in the form of distribution B, and we need to calculate FD and FD dash. Here also we will consider the same assumed mean because class interval is same for distribution A and B. Hence we take the assumed mean as 125, and the mid values are same for both. Okay, if you, as we have calculated for the distribution A, they are applicable for distribution B, and based on the mid values we will get the D dash values. D dash values are also same, minus 2 minus. Now what we need to do, the D dash values which are considered for distribution A are multiplied with the distribution B frequencies, corresponding frequencies. Hence minus 2 into 1.8, that is minus 3.6, minus 1 into 3.2, minus 3.2, 0 into 4.00, 1 into 4.8, 4.8, 2 into 5 is equal to 10, 3 into 2.4 is equal to 7.2. Now d square distribution B frequencies are multiplied with the uh, d square values. That is, if d dash, what we have taken d dash square values. D dash square is nothing but minus into minus 2 into minus 2. D dash we know that minus 2. 4 into frequency 1.8, that is 7.2. 1 into 3.2, 3.2. 0 into 4.00, and we got 1 into 4.8, 4.8. 4 into 5, 20, and 9 into 2.4, we will get 21.6. If you add all the corresponding product of frequencies and deviations, you will have for distribution A, the frequencies are 6.7. For distribution B, frequencies are the frequencies, sum of the frequencies, that is n is equal to 21.2, whereas uh, sigma fd dash, the sum of the product of the frequencies and distributions of distribution A are sigma fd dash is equal to 16.5. Sum of the squared deviations and their product of frequencies is fdd square, that is 67.3 for distribution A, whereas for distribution B we have sigma fd dash, that is equal to 15.2. That means frequencies and deviations, product of the deviations. Okay, then fd dash square is nothing but square deviations product with frequencies and their total. That is sigma fd dash square, which is equal to 56.8. Okay, in the distribution we have first we need to find out x bar, because we require x bar to calculate the coefficient of variation. X bar is nothing but arithmetic mean, which is equal to, as we are considering assumed mean here, x bar is equal to a plus, a means assumed mean, plus sigma fd dash by n into c. We are taking common factor, hence we put d dash, and out of we are taking common factor, we need to multiply it with the same common factor, that is into c we are multiplying. If you substitute the values given in the which we got from the calculation, that is a is equal to 125, sigma fd dash is equal to 16.5, c is equal to 50, and n is equal to 16.7. Now if you substitute, that is x bar is equal, that is 125 plus 16.5 by 16.7 into 50. Okay, 16.5 into 50, you will get 825. Hence 125 plus 825 by 16.7, which is equal to 125. 825 by 16.7 is equal to 49.40. 49.40, which is equal to 174. 0.40, 174.40. Right, now distribution B we need to consider. For distribution B, arithmetic mean is equal to x bar is equal to a plus same formula, sigma fd dash by n into c, where we got a is equal to 125, sigma fd dash is equal to 15.2, c is equal to 21.2, n is equal to 50. Okay, substituting the values in the formula, x bar is equal to 125 plus 15.2 by 21.2 into 50. That is 125 plus 35.85 is equal to 160.85. Okay, now we need to introduce the standard deviation formula, as we got all the requirements, all the required items in the given formula. That is where sigma fd dash square is equal to 56.8, sigma fd dash is equal to 15.2, n is equal to 21.2, c is equal to 50. If you substitute these, that is small sigma is equal to standard deviation formula is equal to, under root 56.8 by 21.2 minus 50.2 by 21.2 whole square into 50. Then under root 56.8 by 21.2, if you simplify, you will get 2.68 minus 15.2 by 21.2 whole square. If you solve this, you will get 0.51 into 50. Under root 2.68 minus 0.51, okay, under root is equal to under root 2.17 we will get into 50. Under root 2.17 value is 1.47. If you multiply the same with 50, you will get 73.65. Okay, coefficient of standard deviation is equal to sigma, okay, by x bar into 100. Coefficient of variation Cv is equal to 73.65 by 160.85 into 100, which is 73.65 by 160.85 is equal to 0.4579, which into 100 is equal to 45.79%. Since the coefficient of variation is low for distribution B, it is more consistent and less variable when compared with distribution A. Right. Next, we have another formula, that is, we have another problem related to daily turnover of two factories. Find out which factory is more consistent. He has asked. He has given standard deviation for factory A and factory B. Mean also he has given for both the factories, and number of observations are also given. Now what we need to do, only we have to consider the formula of coefficient of variation, where we have given standard, we have got standard deviation and arithmetic mean, right? Factory A we will calculate. Standard deviation is given for factory A is 29, and 29 by arithmetic mean is given as 45. 29 by 45 into 100, which is equal to 29 by 45 is nothing but 0.6444, which is into 100, that is 64.44 percentage. For factory B, coefficient of variation is equal to small sigma by x bar into 100, that means small sigma standard deviation is given as 31, and x bar arithmetic mean is given as 50. 31 by 50, which is equal to 0.62, and into 100, then we will get 62%. Factory B is more consistent when compared with that of factory A in the matter of daily turnover, as its coefficient of variation is lower than the factory. Actually this is not lower, but when compare in relative it is lower. Okay, when we compare the with A, the factory B is lower. Okay, it's a relative measure, right? Next, we have variancy. The term variancy was used by R.A. Fisher in 1913. Okay, according to him, it is the square of the standard deviation, that is sigma, small sigma square. Okay, in the words of William Greenwald, the variance is the mean of the square deviation about the mean of a series. Okay, thus symbolically, variance may be expressed as, okay, V is equal to sigma x minus x bar whole square by n. Okay, where V is equal to variance. Sigma x minus x bar, sum of the deviations taken from the mean. Sum of the deviations taken from the mean. When the deviations are taken from assumed mean, variance can be calculated by using a different formula, that is variance is equal to sigma fd dash square by n, sigma fd dash square by n whole square. Why we are taking here fd dash square means only when you have fd dash, when you have a common factor you will have fd dash. Okay, hence you need to multiply the same with the common factor. If you don't have common factor, that means you don't have bigger figures, then you need not worry about the dash. That means you take ft square by n minus fd by n whole square, that's enough. Okay, variance and standard deviation are closely related to each other. Since the variance is the square of the standard deviation and the standard deviation is the square root of variance, it is in a given frequency distribution, a lower degree of variance indicates high uniformity, homogeneity, and conversely less variable. Okay, this is regarding frequency, and now we'll consider one combined standard deviation. Concept is called combined standard deviation. When standard deviation for two or more distributions are combined, it is called the combined standard deviation. The procedure for its calculation is we'll see is given stepwise. First step is compute the combined mean by adopting the formula, that is x bar 1 2. Okay, x bar 1 2. 1 indicates 1 is given for some of the frequencies. Here first 1 and 2 means x bar 1 2 means it is combined of frequencies and arithmetic mean. Dot dot n, you can calculate n number of, okay, combined standard deviation for m number of uh, series, right? Hence we take x bar 1 to dot 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 n, which is equal to n1, okay, into x bar 1 plus n2 into x bar 2 plus n into x bar n. Okay, you can find out for n series, right, by divided by n1 plus n2 plus dot 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 n, where x bar 1 2 dot 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 n is nothing but combined mean of, okay, combined mean for which we are going to consider. N is the number of observations given in the series. X bar is arithmetic mean, or we can say average, okay, mean or arithmetic average. Second step is find the deviations from the combined mean by subtracting combined mean from the mean of the series. Thus d1, okay, or we can say d1 is equal to x bar 1 minus x bar 1 2, and d2 is equal to x bar 2 minus x bar 1 2. If there are two series are given, we will consider like this. Okay, d3 d4 also we can make. If d3 is there, if their number of means, okay, series is given are 3, then d3 also you will have, right? d3 means x bar 3 minus x bar 1 2 3, right? Then combined standard deviation can be calculated by using a formula that is given there. Okay, that is sigma 1 2 dash 1 2 dot n, which is equal to under root n1 sigma 1 square plus n2 sigma 2 square plus n sigma n square plus n1 d1 whole square, n1 d1 square plus n2 d2 square by n1 plus n2 plus n dot 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 n, which is called, where sigma 12 1 2 dot 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 n is equal to combined standard deviation, n is equal to total number of observations, small sigma, which indicates the standard deviation, d square is equal to square of the difference between actual mean and combined mean. Okay, combined mean. Now we'll consider one example for this. Mean x bar is given for group 1 and group 2. Standard deviation is also for given for group 1, group 2. Number of observations are also given. Okay, mean x bar for group 1 12, for group 2 is 15. Standard deviation for group 1 is 6 and group 2 is 8. Number of observations for group 1 is 25 and group 2 is also 25. Calculate combined standard deviation and combined mean of two groups. Okay, here in order to calculate the combined standard deviation and the combined mean, we have x bar 1 2 is to calculate the combined mean. X bar 1 2 is equal to n1 x bar 1 plus n2 x bar 2 by n1 plus n2. Here we know n1 is equal to 25, n2 is equal to 25, and x bar 1 is equal to 12, x bar 2 is equal to 15. Substituting the same in the formula, x bar 1 2 is equal to 25 into 12 plus 25 into 15 by 25 plus 25. 25 into 12 is 300, you will get. 25 into 15 375 by 50, that is 670 by 50, which is equal to 675 by 50 is equal to 13.5. Okay, now we need to calculate combined standard deviation. As we know that formula for combined standard deviation is equal to small sigma 1 2 is equal to under root n1 sigma 1 square plus n2 sigma 2 square plus n1 d1 square plus n2 d2 square by n1 plus n1 n2. d1 is equal to x bar 1 minus x bar 1 2, which is equal to x bar 1 we know that 12, x bar 1 2 we got from okay uh, calculating, that is 13.5. 12 minus 13.5 you will get minus 1.5. d2 is equal to x bar 2 minus x bar 1 2, and the x bar 2 is given, that is 15 minus we have calculated x bar 1 2, that is 13.5. 15 minus 13.5 you will get 1.5. Here to know the standard deviation of combined standard deviation of the given series, we will have all n1 is equal to 25, n2 is equal to 25, sigma 1 is equal to 6 and sigma 2 is equal to 8, d1 is equal to minus 1.5 and d2 is equal to 1.5. Substituting these values in the formula, we will have sigma 1 2 is equal to under root 25 into 6 whole square plus 25 into 8 whole square plus 25 into minus 1.5 whole square plus 25 into 1.5 whole square by 25 plus 25. Then 25 into 6 whole square means 36. 25 into 36 plus 25 into 8 whole square means 25 into 64 plus 25 into 1.5 whole square minus 1.5 whole square means plus 2.25. That means 25 into 2.25 plus 25 into 1.5 whole square is nothing but 2.25. Hence 25 into 2.25 by 50. Now if you simplify 25 into 36 you will get 900 and 25 into 64 you will get 1600 plus 25 into 2.25 you will get 56.25 and the same 25 into 2.25 you will get 56.25. Okay, under root these by 50 is equal, if you add all the values, that is 900 plus 1600 plus 56.25 plus 56.25 by 50, that is 2612.5 by 50. Okay, you will get 52 under root 52.25. If you solve this, that means as the combined standard deviation is asked, we need not okay, that is given as 52.25. If you want to further simplify it, okay, if you find under root for this, you will get that, right? Next, relationship among various dispersion measures. Okay, various measures of dispersion are independent of each other, that we have studied. Okay, in case of normal distribution of the data, these measures show the following relationship in terms of coverage of items. Okay, and mean is plus or minus quartile deviation. Mean plus or minus quartile deviation covers 50% of the items. Mean plus or minus mean deviation covers 57.5% of the items. Mean plus or minus sigma covers 68.27 of the items. Mean plus or minus 2 okay sigma covers 95.45% of the items. Mean plus or minus 3 sigma covers 99.73 of the percent of the items. Okay, mean plus quartile deviation covers only 50% of the items in the distribution. On the other hand, mean plus standard deviation covers 68.27% of the items. Further, standard deviation together with mean value explains greater percentage of items in the given distribution, and that any distribution than any other combination of measures of dispersion with mean. Okay, as such, standard deviation ensures more reliable results, and quartile deviation gives the least reliable results when we go through this. Right, we will come to now. Next, we have merits and limitations of standard deviation. Okay, Standard deviation merits we will see first. Standard deviation is a well-defined measure of dispersion as compared to other measures such as quartile deviation and mean deviation. It is amenable to further algebraic treatment, and it is based on all observations on the distribution. Therefore, it can be treated as more representative measure as it yields almost the same value for different samples drawn from the same population. It is considered to be least affected by the sampling fluctuations. Okay, this measure has greater reliability and therefore it is commonly used in small samples. Okay, next limitations. If we go through the limitations, it is not an easy. Okay, to calculate the it is not easy to calculate the standard deviation as it involves calculations of squares and square roots, etc. Base its value is affected by extreme items in the distribution. Okay, despite these limitations, it is widely used in comparing the variability of different distributions. It is also used in different statistical techniques like skewness, kurtosis, correlation analysis, regression analysis, tests of significancy, analysis of variancy, etc. It is also considered as the unity of measurement in normal distribution, right? And we have Lorentz curve. Lorentz curve is nothing but a graphical method used to solve the dispersion. Okay, studying the dispersion. Lorentz curve is a popular. Okay, the dispersion in distribution can also studied with this graphical method. Lorentz curve is a popular method of presenting variability of a distribution on graph. It has been first developed by Maxwell Lorentz, who used it to measure the variability in the distribution of income and wealth. Okay, this technique can also be used to study the distribution of profits, wages, turnover, etc. Okay, the Lorentz curve is a cumulative percentage curve. A diagonal line drawn across O of origin, that is O of x-axis, and 100 of y-axis. 100 of y-axis is called line of equal distribution. Line of equal distribution. This is shown in the figure 19.1. Okay. Uh, I mean, this is shown in the next PPT. The departure of frequency curve from this line shows the degree of inequality and of variability in the distribution. Greater departure of curve from the line of equal distribution reveals greater variability and less consistency, and vice versa. The following procedure is used for the construction of Lorentz curve, that is, find out cumulative frequency, okay, cumulative totals and cumulative percentage for the size of the items values. Items is nothing but values, and for the frequencies. The percentages can be obtained by taking the cumulative total as 100 and obtaining the percentages of each value. In case of continuous classes or continuous series, mid value are taken to find out the percentages. And second is plot the cumulative percentages of frequencies stating from 100 to 0 on the x-axis, whereas on y-axis the cumulative percentage of variables are to be shown. Draw a diagonal line joining 0 and 100. This line is called the line of equal distribution. And the fourth one is join the percentage value of each variable, okay, plotted on the graph to obtain the frequency curves. Dispersion is measured by taking the extent of departure, okay, of these curves from the line of equal distribution. Okay, here the he has given a data and asked to locate the Lorentz curve. Okay, draw a Lorentz curve. He has given data relating to wages paid in two factories. Draw Lorentz curve to measure the dispersion of wages, he has asked. Wages he has given, that is uh, 5, 10, 15, 20, 25, 30, 35, 40. Number of persons, factory A and factory B is given. For the sake of convenience, the data given by the examiner is represented with red color, and which we have, okay, calculated given in black color. Okay, then see, x is given and we need to calculate cumulative totals and cumulative percentage. Okay, cumulative totals is nothing but what it has given, that is cumulative. That means if you take wages, that is 5 10 which are given, cumulative totals 5 plus 10 15, 15 plus 50 30, 30 plus 20 50, 50 plus 25 75, 75 plus 30 105, 105 plus 35 140, 140 plus 40 180. These are cumulative totals. That means you are first to the second and second to the third, third to the, then you need to put according to them. First you don't have to nothing to add, then it is 5 plus 5 5 only. For second you have preceding one, that is 5 plus 10 15, 15. These are cumulative totals, and you need to take cumulative percentages. Okay, cumulative percentages. If you consider 180 as 100%, you will take 5.5 is in the 100, you will have 2.8. Okay, 2.8 will be the percentage. Now factory A, in case of factory A, frequencies are given, that is 10, and in the same manner you have to in the same manner that what you have done in case of wages, that is cumulative totals and cumulative percentage, you need to accumulate the totals of the frequencies given as, okay, number of persons of factory A, factory B. Factory A is 10, 10 first we don't have anything, 10 plus 10 is 10 only, 10 plus 22 32, 32 plus 30 62, 62 plus 50 112, 112 plus 40 152, 152 plus 20 172, 172 plus 20 192, 192. Okay, there is nothing has given, it is 0. Has given 0 is nothing but nothing has given, hence we take 200. Okay, 192 plus 192 plus 8, here it is wrongly mentioned, that is 0, but he has given 8. 192 plus 8 200. Next we need to have cumulative percentages. Okay, that is if you take 200 as 100%, you will 192 will you will get 96. In the same manner, 10 is 5%, and okay, 32 is 16%, right? 32 is 16%, and 62 is 31%, 112 is 56%, 150 76%, 172 86%, 192 is equal to 12%, and 200 is equal to 192 is equal to 96%, 172 is equal to 86%, and 200 is equal to 100%. In the same manner, you have to consider for factory B. For factory B, has given frequencies, and we need to cumulative totals, that is 8 plus 12 20, 20 plus 30 50, 50 plus 50 100, 100 plus 40 140, 140 plus 26 166, 166 plus 12 178, 178 plus 22 200. Then you need to consider cumulative percentages. 200 is equal to 100%, then 8 is equal to 4%, 20 is equal to 10%, 50 is equal to 25, 100 is equal to 50, 140 is equal to 70, 166 is equal to 83, 173 8 is equal to 89, 200 is equal to 100%. And here number of persons is F, wages in Marcus X. C totals is nothing but cumulative total, C percentages nothing but cumulative percentages. With this we can draw a curve, Lorentz curve. Okay, that is, if you look at the PPT, you will come to know. Okay, and there in the yellow curve is shown the B factory, okay, wages, and red curve shows the factory A, where C is the line of equal distribution, that is given in this. Okay, with this we conclude the class. Thank you.